Hi everyone, I hope you're all right. Today, I posted on Edmodo what I wanted to look through for this week. So it's past paper, it's functional skills level 2 paper. So I'm going to run through the solutions. If you haven't already done it, please go back and have a go at all of the questions. And then once you've done that, watch these videos and then you can go through and you can check your work against what I've done here. I'm only going to show one method of doing each thing. There will be different methods of doing it. So as long as you get to the right place, that's okay. If you do have any questions, you can email me or you can message me on Edmodo, or if you want to mark your work, please just take a photo of it and then send that over, and then I can annotate it and send it back to you. Okay, so question one, Georgie is a plasterer and she needs to buy 6 bags of plaster and she finds these prices. So the number of bags, 1 to 4, £4.97, and 5 or more, £4.48. Also says VAT of 20% is not included in these prices. So she's buying 6 bags, so we're going to be looking at this price. So the price for 5 or more is £4.48 per bag. So first things we need to do is say 6 times £4.48. If you work that out, it's going to give us 26.88. So £26. Oops, apologies. £26.88. But this does not include the 20% VAT. So we need to find 20% and then add it on. If this is on a calculator paper, what we can simply type into our calculator is using a multiplier. We're going to add on the 20%. So our eventual price is going to be here, it's 100%, and we're adding on 20%. So our total price at the end is going to be 120%. And remember, if we want to change that into a multiplier, we need to divide by 100. So we're changing it into a decimal. So my multiplier is going to be 1.2. So I come back to my price was 26.88. And then I'm going to use my multiplier, which is 1.2. And if I work that out, it's going to give me 32.256. And this is pounds. So the last thing I have to do here is change this into how I would see it in a shop. So I'm only going to have 2 decimal places after the point. So I need to look at this 5, and if I look at the number next to it, because 6, that's going to round up. So my final answer is going to be £32 and 26 pence. Okay, so the second part of this question, Georgie charges £15 per hour to plaster. She knows it takes 20 minutes to plaster an area of 1 metre squared, and she needs to plaster an area of 58.5 metres squared. So how much should she charge? So 1 metre squared, it's going to take her 20 minutes. And we need to find out 58.5 metres squared. So 58.5. And then we can multiply that by 20. So the total amount of minutes it's going to take her is 11. So it is 1,170 minutes. And she charges £15 per hour. So we need to change from our minutes into hours. We do that by dividing by 60, because there's 60 minutes in an hour. So do that calculation. It's going to take 19.5 hours. And then if we look at our rate, it's £15 per hour. So the last thing we have to do is just say 15 times by 19.5. And if we work that out, our calculator is going to show 292.5. Again, it's money, so we have to remember a pound sign and the 0 at the end. And that's our final answer. We also have to show a check here. So this is a 4-mark question. So it's 1 mark for the check. For the check, we're just going to do a reverse calculation. So our final answer was £292.50. And to get to that, we multiplied by 19.5. So the opposite of multiplying, just going to divide by 19.5. And if we do that, it'll take us back to £15, which was our rate of pay. We also have to show a check here. So this is a 4-mark question. So it's 1 mark for the check. For the check, we're just going to do a reverse calculation. So our final answer was £292.50. And to get to that, we multiplied by 19.5. So the opposite of multiplying, just going to divide by 19.5. And if we do that, it'll take us back to £15, which was our rate of pay. Okay, so question 2 is an area question. It's a bit funny because it's given us a scale diagram of the wall. So that doesn't give us the measurements here. So you actually have to take out your ruler and measure them. So I've already done that, and I found that one is 9 centimeters and the other is 5 centimeters. Second thing we need to do is look at the scale. So the scale is 1 to 50. So for every 1 centimeter here, it is equal to 50 centimeters in real life. So I need to multiply both of these by 50. It's going to give me 450 centimeters. And then if I multiply 5 times 50, it's going to give me 250 centimeters. It also says the door is 2 meters by 80 centimeters. And then we've got some plaster comes in 7.5 kilogram bags. And that much plaster covers 3 meters squared of wall. So we're going to work in meters for this. So we're going to change all of these to meters. So to change to meters, we just divide by 100. So this is going to be 4.5 meters. And it's going to be 2.5 meters. So our dimensions, 2.5 meters by 4.5 meters. For the door, it says it's 2 meters by 80 centimeters. So again, we just divide by 100, and that's going to give me 0.8 meters. So now we're going to start to work through this. So she thinks 4 bags will be enough. So we're going to find the area of the wall and the wall alone. So first of all, we're going to find the area of everything. Then we're going to take away the area of the door. So the area of everything, we're going to do 4.5 times 2.5. If we work that out, it's going to give us 11.25. It's 11.25 meters squared. And then we need to take away the area of the door. So the area of the door, we'll find first of all, it's 0.8 times 2, which is going to give us 1.6. Meters squared. And then we need to take away the area of the door from the area of the whole wall. If we work that out, that gives us 9.5 9.65 meters squared. So the total area is 9.65 meters squared. It then says that 7.5 kilograms of plaster, which is one bag, covers 3 meters squared of wall. And she thinks 4 bags will be enough. So if we work this out, we could say, all right, one bag is going to cover 3 meters squared. So 4 bags is going to cover, just times this by 4, 12 meters squared. So she needs to cover 9.65 meters squared. 4 bags covers 12 meters squared. So is she correct? Yes. There's a lot of marks on top of that. That's 6 marks, but there's loads of stuff going on. All right, next we've got a ratio question. It's quite a horrible ratio question. So we've got a ratio 3 to 1, and that's glue to water 3 to 1. But she needs 5 litres of the mixture, and she has 3.5 litres of glue. So we need to say, does she have enough to make 5 litres of the mixture? One way of saying this, doing this would be to say, if I used 3 litres of the glue and 1 litre of the water, in total, I would have 3 plus 1, 4 litres of mixture. So all I would have left after I've used the 3 litres of glue from 3.5 would be 3.5, take away 3. So I've now got 0.5 litres of glue left. So I want to make as much as mixture I can with what I've got left. So if I'm looking at the same ratio, but now I've got 0.5 litres of glue, I can say that this is, if I divide by 6 from my original ratio, that's what I'd have here. And if I do that to one side, I have to do it to the other. So the amount of water I would need would be 1 divided by 6, or 0.16 recurring litres of water. So the total I can make for this mixture, with what I've got left of the glue, would be 0.66 recurring litres. So in total, the maximum I could make would be 4 plus the 0.66, or 4.66 recurring litres. So she says, does she have enough to make 5 litres? No, she can only make this much, 4.66, so we have to say no. That is quite a horrible question. I think it's a very, very difficult ratio question. I don't expect anything that difficult to come up again. So next question, Barney's cooking a chicken and he's got these instructions. So he's going to cook the chicken at 180 degrees for 20 minutes per 500 grams, plus 15 minutes. And then he's going to rest the chicken for 10 minutes before serving. And the chicken weighs 1.8 kilograms. And the question says, what's the latest time he should start cooking if he wants to serve by 2 p.m.? So the first thing we need to do is here we're working in grams, so we're going to change this into grams. And 1.8, if we want to change that into grams, we should multiply by 1,000, because 1,000 grams in a kilogram. So that's 1,800 grams. And we need to find out how many times 500 grams goes into this. So we can do 1,800 divided by 500. If we work that out, we're going to get 3.6. So for every 500 grams, we need 20 minutes, and there's 3.6 times 500 grams. So then we need to say 3.6 multiplied by 20 minutes. So that is 72 minutes. He also has to add on 15 minutes and then 10 minutes to rest the chicken. So we're going to do 72 plus 15 plus 10. So if we add all of that together, we've got 72 plus 15 is 87. 87 plus 10 is 97 minutes. And then 97 minutes, we want to write it in terms of hours because we're going to start working backwards from 2 p.m. So we can write that as 1 hour, 37 minutes. And then we want to find the latest time we can start cooking. So we need to go backwards by an hour and 37 from 2 p.m. So if we go 2 p.m., take away an hour, it's going to give us 1 p.m. And then we want to go backwards again by 37 minutes. So that's going to take us to 12:23 p.m. So next question, Barney's got an oven and he's going to use gas marks. So he uses formula to convert 180 degrees C to a gas mark. So a gas mark is just another way of saying a temperature. I'm not really sure why we use it. But anyway, with our formula, G is the gas mark and T is the temperature in degrees C. And he thinks gas mark 6 is the same as 180 degrees. So all we need to do is say T, or the temperature, is equal to 180 degrees. And then we're just going to substitute that into this formula and see what gas mark we get out. So we need to do 180. So I've just replaced the T in the formula with 180, take away 121, and then we're going to divide that by 14. And if we type that on this calculator, we're going to get out 4.214, etc., etc., etc. So we can say that he thinks it's going to be equal to gas mark 6. Is he correct? No. If he was correct, what would have come out here would have been just 6. Next question, Barney's going to make a cake and he's going to use 250 grams of flour. He adds 14 grams of baking powder for each 150 grams of flour. We need to say how much baking powder does he need to add to the 250 grams of flour. So again, we're working with ratio, and we've got our baking powder to our flour. And we need to add 14 for every 150. And we need to find out how much he wants to add to 250. So we need to find a way of going from 150 to 250. So we're going to do a step in the middle, and that is to find out how much we would need if we were just going to bake with 50 grams of flour. So we can say, how do we go from 150 to 50? We divide by 3. So we have to do the same on this side. So we do 14 divided by 3. Which is going to give us 4.6 recurring. Then we need to say, how can we go from 50 to 250? We're going to multiply by 5. So we're going to do that to both sides. So if we multiply that by 5, that's going to give us 23.3 recurring grams. So that is our final answer. It says, sorry, give your answer correct to the nearest gram. So the nearest gram we need to do some rounding. So if we look at the 3, it's lower than 5, so we're going to round down. So it's just going to be 23 grams. That's your final answer. Next question, we're using a conversion graph. And we want to convert 12 ounces into grams. So here's our weight in ounces, and here's our weight in grams. So what we can do is we can go along to 12 here, read up to the line, and then read across. So first of all, I need to pinpoint where 12 is here. And if I look at how many divisions there are between 5 and 10, there's 10 divisions. So each 2 of these little boxes is equal to 1. So I need to say this one here would be 11. It's quite hard for me to do this accurately. So this would be 11, and this would be 12. So that's my 12 ounces there. And then I'm going to read up to the line. Ideally, I'll be using a ruler for this. It's going to be very, very inaccurate. So this is meant to be a straight line. Read up to the line, and then read across to the weight in grams here. So that's right in the middle of 300 and 400. So that's going to be 350 grams, and that's my answer. I looked at the mark scheme, and they actually, any answer between 345 and 355 they would accept. So there's a small amount of leeway. So around 350 is fine. Okay, so he's going to put the cake mixture into a tin, and he's got 2,200 centimeters cubed of cake mixture. So if we see centimeters cubed, we know that it is going to be a volume question. It's got 2 cake tins, one with a rectangular base and height of 7, one with a square base and a height of 5. So if we look at tin A first, we've got rectangular base and height of 7. For the volume of a cube or a cuboid, all we need to do is times the length by the width by the height. So for A, we've got, let's say the length is 21 multiplied by 15 multiplied by the height is going to give me 21 times 15 times by 7, 2,205 centimeters cubed. And then for B, it has a square base of side length 23. So if it's a square, that means the sides are going to be equal. So the length is going to be 23. The width is going to be 23. And then the height is 5. Times 23 times 5. And that gives me 2,645 centimeters cubed. So which tin should you use? Give a reason for your choice. He needs to fit 2,200 centimeters cubed into it. So in actual fact, he could use either of these. And the mark scheme says you can say either because the cake mixture would fit into both. So it's going to fit into both. So next question, Jai is a driving instructor and he thinks he travels an average of 500 miles each week, and he records these figures for 5 weeks. So we've got the number of miles and the weeks, and it says, does he travel an average of 500 miles each week in these 5 weeks? So it's talking about an average. We could actually find the mean here. We could actually find, say that again. We could find the mean or the median. I'm going to find the mean. So for the mean, I add them all together and I divide by how many there are. So 478 plus 524 plus 511 plus 496 plus 473. And if I add those all together, 478 plus 524 plus 511 plus 496 plus 473. So that all adds together to give 2482. And then I need to divide by how many there are. So there's 5 weeks. So divide this by 5. And my answer is 496.4 miles. So does he travel an average of 500 miles? No. He travels just a little less, 496.4 miles. Also got a check here, so we're just going to do the opposite. So we ended up with 496.4, and we divided by 5 to get there, so we're just going to multiply that by 5. And that's going to take us back to 2482, which is what we had before that. So question 7, Jai wants to find out which driving school is the cheapest price for 15 lessons, and he's got 3 choices. He thinks pass first is the cheapest. We need to say if he's correct. So first of all, we're going to look at safety drive. So number 1, we're going to look at safety drive. So for safety drive, it's £23 per lesson, but if you pay for 10 lessons, you get your next lesson free. So in total, you're only going to pay for 14 lessons. So we're just going to do 23 multiplied by 14. If we work that out, we're going to end up with £322. So that's option 1. Option 2 is pass first, and they're £25 per lesson, but if you pay for 10 or more, you get 17 off of the total price. So find out what it would cost without the discount, which is just 25 multiplied by 15. It's going to give me £375, and then I need to find the cost if I get 17% off. So I'm going to do this using multipliers. You could just find 17% and take it away, but this is a slightly quicker way. So our original price would be 100%. And then we're going to take away the 17%, which is going to leave me with 83%. So I want to find 83% of it. And I can change that into a multiplier just by changing it into a decimal. So dividing by 100. So it's 0.83. So I can times 375 by 0.83. And if I work that out, that's just going to give me £311.25. So that's option 2. And then option 3, it's nice and simple, just £22 a lesson. So 22 multiplied by 15. If I work that out, I'm just going to get £330. So Jai thinks pass first is the cheapest. Is it the cheapest? Yes. So now Jai is going to travel from Oxford to Aberdeen, and he's got some information about distances. And he knows that his car covers 44 miles per gallon, and his fuel tank holds a maximum of 50 litres of fuel. 1 litre is 0.22 gallons. So can he drive from Oxford to Aberdeen using only 1 fuel tank? So first thing we need to do is find the distance. So we read that off. Aberdeen is here, Oxford is here. So we read across, and the total distance is 503 miles. So 503, that's a 0. 503 miles. Next thing I have to do is a little bit of conversion. So his tank holds a maximum of 50 litres, and 1 litre is 0.22 gallons. And because it's in gallons here, miles per gallon, we want to change that into gallons. So we can do that is say 50 multiplied by 0.22. I've worked that out. It's just going to give us 11 gallons. So 11 gallons and 44 miles per gallon. So for 1 gallon, it's 44. So for 11, we're just going to multiply it by 44. Which is going to give us 484 miles. So he's only going to be able to get 484 miles, but he needs to get 503. So can he do it on one tank? No. All right, so last question. Jai wants to compare fuel costs with an electric car with a petrol car. Petrol car, 44 miles per gallon, and 1 gallon costs 549 pence. For an electric car, 3.2 miles per kilowatt of electricity, and 1 kilowatt costs 9.7 pence. And he thinks the cost of fuel for the electric car is a quarter of the cost of fuel for the petrol car. So we want to say if he's correct. So we can say for the petrol car, 44 miles costs 549 pence. And then for the electric car, 3.2 miles costs 9.7 pence. So for the petrol, we're just going to find out the cost per mile. The way we do that is we just do 549 divided by 44. So that's 12.47772, and the 7 and the 2 are recurring. So that's for the petrol. And then for the electric, we're just going to say 9.7 divided by 3.2. And that gives us 3.03125. So this is 12 point blah 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 p, and this is 3.0312p. And he thinks the cost of the electric car is a quarter of the cost of the petrol car. So we can write this as a fraction, and we'll just put this into our calculator. 3125 divided by 12.4772, and those are both recurring. So you can put that into a scientific calculator. So if we put that into a calculator, we're going to end up with 0.242, 9 recurring, and then a load of other numbers. And we know that a quarter, if you write that as a decimal, is 0.25. So is it a quarter? Is it 0.25? No. And that's the end of the paper. I do think that this paper is a fairly tricky one out of all of the ones that we've looked at. I think it's quite difficult.